Joe Novosel, he's been writing his challenges every month, which has helped a lot for the newsletter, and we appreciate that. And yeah, and Joe's going to give us a nice presentation tonight, so let's get to it.
Okay, thank you very much. Thanks, Julia. Julie or Julia? Your choice. We want the lights down or up? What do you think? Up? We're good. We're going to stay up. Okay, so most people may remember me more these days as being involved with the Fort Wayne. No, we still want them. We still want them up. There was a request by the camera to leave them up. I've been involved lately with just the spectroscope, and that's taken up an awful lot of my time over the past 3 years. But before that, in fact, since about 1987, I've been doing visual astronomy. I got into it again with Halley's Comet, and have been mainly involved in visual astronomy since Halley's Comet. So quite a long time. So it's what I have most of my equipment for, and I think I've developed some tools and techniques that have helped me along the way, and I'm going to share those tonight for any of the beginners that need to have a boost on how to get that new Christmas telescope going and look at something other than the moon. We don't even have planets right now to look at, so you kind of stuck with the moon, which is not a bad thing. But looking at the same thing over and over again is not something that builds confidence in your equipment or enjoyment with the hobby. So I'm going to try to give you a few tools, techniques, and tips to get over that hump, to get going. And if we're lucky, we'll have a few newbies from the group get on the YouTube link and take a look at the video there. So it's for all of those folks as well, primarily for those folks.
Gave us their email address. I sent out stuff already.
Yes. And they'll have to pick it up on the YouTube. So their loss. Yes. So, well, that's not good. Oh, there we go. Go the right way on the wheel, it all starts to come together. So what I want to talk about tonight is this laundry list of things. We'll go through this rather quickly. There's not that many slides, I don't think. So you see all these Hubble pictures, and all these fancy things like what Geddes does and other people, they put together these amazing astrophotographs, and then you go by your 8-inch Schmidt-Cassegrain and you set it up and you go, wow, this is a lot different. So I want to. Yeah, and there you go, and you're up to speed. So I want to go into that, set expectations to really give you an idea of what you're going to see. And one of the keys to this is figuring out what you want to look at. And if you don't know what you want to look at, it's hard to look at anything. It's kind of a chicken and egg thing. And so I want to go through a process of planning sessions. I found it very useful. Even with spectroscopy right now, I do a fair amount of planning to know what I want to do and all the setup parameters. Like, you have go-to, well, that's great, but there's usually, if you're setting it up for every session, there's usually a 2-star calibration that's involved, and you have to do a go-to calibration, or you have to do the go-to calibration without the 2-star alignment. But in some way, you have to do a calibration, and you have to have some stars picked out for that. So, and for the very newest, we want to look at one simple way to find Polaris. If we were going to be out at the observatory, which I guess I have to apologize for tonight, I expected it to be raining right now. At least my weather app led me to believe that we would have total cloud cover and possibility of rain. So we ended up here instead of at the observatory. So I don't know if that's good or bad, but with the weather risk that we had, I thought this would be the better place to have it. We at least wouldn't be crammed into the control room or out on the floor. Yeah, definitely, and not as humid. And then we'll take questions, and we won't be doing any hands-on. So we'll put out a notice at some point identifying possible times for other hands-on help with people that have Christmas telescopes, if you will, that need to have a little help setting up and getting things running. So the normal way to do that would be to bring it out to a public viewing on a Saturday night, if we ever have clear skies again, and we could go and do it at that time as well. So let's get started with this question. And the question is, you have a new telescope. Now, what do I do with it? And my answer to that, do we have a question? Oh, okay. Thank you. I believe you need to read. This hobby is a technical hobby. It demands you to, it requires you to read to figure out how to do things. And one of the things that I insist that you do, I have done it, is to read your manual, Pete, and reread it until you basically know it. You have to know how all of your equipment works, how it all fits together. You have to be able to do it literally in the dark. If you're fortunate enough to get good viewing nights in the fall, you're going to be setting up in the dark. So you have to read and know your manuals. And then there's reading that has to do with all the objects that are available to us. You know, you want to know where they are, you want to know what they are, and you want to know how they work. And a series of books will be handy for that. And I brought a small part of my library just to illustrate some of the books that would be handy for anyone that's new and needs a book list, needs a reading list. There's a series of backup slides that are in this presentation, and I have my book list along with links to various things like our groups.io page, so you can join in on the conversations. And I will post this presentation if I'm able to. That is to say, if our groups.io membership allows for posting of fairly large, medium large files, and I think it will, because we've seen photos from Geddes that are larger than this presentation, I think. So I'm going to do that. And if you don't have a groups.io account and you don't want to get one for some reason, just come up and sign the sheet, and I'll email it to you. So no problem there. Either way, I'll get it to you so you can get all that. A really handy way to get started if you're very new is to watch the Kalamazoo Astronomical Society's 5-part astronomy series. Mike identified that, and I've looked at them, and they're really, you know, for the beginners, it's a very good way to start, to take a look at that. They're lengthy. They're between 40 minutes and I think a little over an hour on some of them. But if you're going to invest the money, you should invest the time to know what to do and how to, and where the things are that we want to look at. So yeah, you need to become expert in setting up all of your equipment. And one way to do that is to actually take advantage of whatever you can see in the sky at your house. Traveling to the observatory is nice, you know, but it's quite a distance, takes up a lot of your time. There's nothing like just getting out and setting up, even though you might have lights and such, but you need to get really up to speed on putting your own equipment in operation. And then I say plan your sessions. Know what you're going to look for. Don't waste the night trying to figure out what to look at. Have something in mind. And a lot of these books that are up here are exactly for that. They're organized by constellations. So you need to learn your constellations. And then you need to learn some observing techniques like averted vision, star hopping, sketching, and a number of other things. And the publications like Sky and Telescope and Astronomy are really good for that. And getting out and practicing and reading your manual, as it turns out. So that's the last bullet there, is observe and enjoy the night sky as often as you can. Getting out into the yard, easier for the kids and the wife. And if you're just learning to put your equipment together, the stuff that you forget and leave in the garage or in the house, it's easier to walk in, get it, and put it together, rather than cursing your bad luck and getting back in the car and driving home, which I've done a few times. Anyway, I found that astronomy has been an amazing lifelong experience. I never expected to get deeply involved in near science work with the spectrograph, so you just never know where it's going to lead. And for me, it's led to a lot of enjoyment. I don't go to star parties anymore, but that used to be a big part of it. So let's see. What can we see? What can we see? What can we expect to look at? Well, on cloudy nights, this is about it. And the first thing that we could look at is the sun. Now, the sun, as we all know, is really bright. And if you're going to look at the sun, you'd better have specialized equipment. So you're going to have something like an H-alpha telescope or a Herschel wedge, or at least you know, a white light filter to go over your telescopes so that you can do that. This image is what you would see if you had just a Herschel wedge or a white light filter. This was taken. This was one of my pictures, so it was taken with a 92 millimeter refractor and a Herschel wedge. So the sun is one good one, but I would save that for later because of the need for special equipment, which can be expensive. But what isn't in astronomy? What most people start with is the moon, and the moon is really a pretty interesting object. It's got a lot of variation in its features, and if you start pursuing craters and all of the other features that are on the moon, the rills and the rays and all this, it turns out to be a pretty fascinating object. And I found, after I got my 5-inch refractor, that the moon actually turns out to be an excellent object. The higher power you can get on it and the clearer the imaging, the more you'll appreciate the moon. So if you're using a Newtonian, make sure it's columnated really well and that you have good conditions, because following the shadow across the terminator across the moon is just an excellent way to spend an evening. I love seeing the shadows grow and change, and I love seeing the crater peaks poking up out of the darkness. It's just interesting and fun to watch it move. It is motion. It's one of the few ways you get motions in astronomy, and so that's one of the ways to do it.
What's the difference?
Yeah, the lighting changes are amazing of what they'll do to the views. And if you know where to look, like right here, right here, right here, that's the Apollo 11 landing site. So you can even chase the landing sites, and the maps aren't hard to find. They're pretty easy actually, and then to look on the moon and find them. It's just a matter of figuring out the left-right reversals and the rotations in order to make the lunar features match up with the landing site photos. Planets. You know, I like to say 9 planets. And this is just the 4 that are most visible. Everybody knows Saturn, Jupiter, and Mars. I imagine everybody here knows what this is, right? Everybody knows this? Who knows what this is? Oh, come on, this is the horns. This is the horns of Venus. This is Venus. This is Venus in its waning phase, waxing phase. So four planets that you've got to look at, and 3 of the 4 show, well, 2 of the 4 actually, just Jupiter and Mars show a lot of motion as well, a lot of changes in the view over the course of an evening. We even have a shadow transit in process on this. And the great red spot will rotate across the sky, and the better your refractor, you know, the more features you're going to see. It's really fun to watch all this go by. When is Mars coming up again for us with a good view? Is it this year or next year? Yeah, I didn't check that. But it's always a joy to look at and watch it go by. And we get into minor planets, which I've never gotten into. I know Pluto's gotten demoted, but even before it got demoted, it was a real tough job to find it and to confirm it, because it really is very little more than a star. So it's just a checklist, you know, checklist item, check the box. But the rest of them, I think, move. They're a bit closer than Mars, and so you can get into that. That's always fun. And then comets. Comets. The thing about comets is they're great to look at. They usually require binoculars, but we've really been in a dry spell for comets. the 90s was just excellent. We had all kinds of comets in the 90s, and it was a real privilege to be around to see the Shoemaker-Levy 9 that bashed into Jupiter, and to see all those burn marks in the atmosphere, those black dots that came in, and to watch them dissipate as we went along. But there were so many good comets in the 90s. They're just not dependable. Then we get into stars. Turns out the more you know about stars, the more interesting they become. And that I say based on the 3 years of experience with the spectroscope. But single stars, require something like a spectroscope. It's pretty specialized to do that. But when you get into the binary systems and you get color involved, then they're really pretty interesting to look at. The viewing session, the public viewing session before last, I was out showing people multicolor binaries, and everybody really liked them. It was surprising. We looked at 3 of them, and everybody was just ooh and ah. This is so cool. Color. You get color. Where else do you get color in astronomy? Well, Mars and Jupiter, Saturn, and the odd reflection in planetary nebula if it's bright enough. Otherwise, it's not that colorful. So people like to see the color, and then when you look at it and you tell them it's like 3,000 light years away, it's really impressive. So I can recommend binaries. Then we get into all the nebula, reflection nebulas, planetary nebulas. This is a great planetary nebula photograph. Yeah, I did it. Probably the best one I've ever made and probably ever will. I have a soft spot for planetary nebulas. I just think they're so cool. There's only about 3,000 of them. And so you're looking, yeah, there really aren't that many. Stars die and all that. And what happens is after a million years or so, they just dissipate. They're just gone. They're expanding and they just disappear. So there aren't that many. So cherish them while we have them. M27. That one's, yeah, it was stunning, really, considering who took it. So then you get into multiple star groups like open clusters. I've never been enthusiastic about open clusters, but again, you'll find some colorful stars in there. One of the Messier objects has an embedded planetary nebula. I forget which one that is. It's a 40 something or another, 44 maybe. Yeah, I forget which one, but it's there. We could look it up in the Messier objects book and see which one it is. That would answer the question. We'd have to leaf through it though. Globular clusters, they come in all shapes and sizes, and so they're a little bit more interesting to me. And one of the summer showcase objects is M13, so can't beat M13 for a good show. Galaxies, that's a fine galaxy. Boy, oh boy, if you could see that in your telescope directly, wow, that would be amazing. And then galaxy clusters. I think this is Stephan's, and you need a decent sized telescope to see Stephan's, and you hardly ever see that much nebulosity around it. You hardly ever see the structure like that. So, but these are the things that we can see, and to me, they've held my interest for many years. And once you get into it, you start finding them and making a habit out of it, they'll keep your interest for a long, long time. So, having looked at all these beautiful pictures, what should we really be thinking about when we start to look for these things? Well, you shouldn't expect real bright views like we were just looking at. You shouldn't really expect fine structure, like all of this structure in the black M64, the Black Eye Galaxy, or in the Eskimo Nebula. You really won't see that. If you're lucky, you will see structure on the order of these sketches beneath. I matched up I found images of those that I had sketched out. And you'll notice the dates on these. They're from quite a ways back. But this is what it looked like, as best I could record it by hand through my 18 in 1998. So that's really what you should be thinking. And in my opinion, that means that you should be getting some source material, some reference books that actually include sketches so that you have a better idea of what you're going to see, rather than the really beautiful images that kind of deceive you. So you should have something that helps you gauge the real view. Okay, so continuous self-education. That's what this is all about. Read and research. So in order to do that, if you're starting out, I would suggest subscribing to one of the popular magazines, Sky and Telescope or Astronomy. You have a relatively recent Sky and Telescope. It should recognize this. And one of the main reasons is that they give you technique. They'll tell you about technique, and they will give you articles about what's to be seen in a particular month. Since this comes out monthly, I was hoping to be able to find this more quickly, but I can't. So we'll come back to it. And then they do actually give you some technical details about how some of this stuff works. So you get a lot of information out of it after subscribing to it for many, many years. I finally stopped. And so anyway, you should get that. Yeah, they'll do all these things for you. They'll even tell you which eyepieces and filters. Get a subscription. Get a log-on credentials for cloudy nights. It's free, so you got nothing to lose by signing up, and you'll be able to look at other people's observations, their pictures. You can get advice on equipment. You can bring your tales of woe to people that have similar equipment, and hopefully someone will actually give you sound advice, and you'll be able to fix it and get going. And if you're brave and you want to get a bargain on your equipment, you know they have a really good used equipment area. I found that their books are generally overpriced, so I don't buy my books on cloudy nights. Astromart is another one, but that's a subscription service that's a whopping $15 or $20 a year. Usually it's just for buying equipment, but you never know what you'll find there. You can look at it, but you can't bid unless you have a paid subscription. So anyway, to emphasize again, you need to become the expert on your telescope. You need to read the manual, and you need to practice. Have I said that before? I'll probably say it again. Practice, practice. Another reason to be out in your backyard, day or night. The books that you get, like these, you can pick up used now, and they're just a fraction of their original cost. This is my latest purchase. I've been meaning to get this for decades, and it was like $8, so can't beat it. And there's a Caldwell list. That would be a good one to have as well. Includes photographs, sketches, and written descriptions. Finally, you really need to learn the constellations. You really, really need to. Even if you have Go-To, you still need to learn the constellations, I think. Why? Why learn constellations? Well, handy to know where Polaris is if you actually have to do a polar alignment on your scope. That's a good thing to know, and know what constellation it's in. Turns out the objects are usually organized by constellation. So if you know where the constellations are and when they're up during the year, you can figure out whether you can see them. So Cassiopeia. Here's a whole section, a whole chapter on that, and all of the others. So you should know them to know what's available to you on a particular night. You will need to have a couple of stars available for calibration purposes, for 2-star alignments or Go-To syncing. And so you at least need to click on something, Stellarium, what have you, in order to get the right catalog numbers, in order to do those things as well. And God forbid that you should have to use a telescope that doesn't have Go-To. What a horrible night that would be. And so you better know some constellations in order to find things and to get around. How do you learn your constellations? Well, read, go out and look for them. Get with someone that knows where they are. And there's a Astronomical League program called Constellation Hunter. And so you can go to the Astronomical League website, and you can get the details on how to do that program. And by the time you're done with that, you should know where your constellations are, and you'll get a certificate if you turn in your log, which is kind of neat. So let's see, how do we find Polaris? Everybody recognize this constellation? Yes, Ursa Major, that's right. And so if you do this, you'll find Polaris. You find the two stars at the end of the Dipper, and they point right to Polaris. Pretty cool, huh? If you didn't know that, that's a good thing to know. That's one of the first things you should know. Know where Polaris is and how to find it. This works pretty well in light polluted areas as well. So let's see. What else can we do with this? Well, if we want to find out, if we want to investigate this upcoming nova, we'll need to know where the constellation Coronae Borealis is. And that's where it is right there. Well, that's really easy to find on the stellarium screen, but how do I find it outside? Well, using that same constellation, you can, that's where T CRB is going to be, Coronae Borealis. All you have to do is line up other Dipper stars. No, really, no, come on. Oh, I can do that later. Anyhow, you come down here on these two. Not sure why the animation didn't work. It's kind of annoying. We'll see it later. It points right to Coronae Borealis, and you'll notice that the constellation Bootes and Hercules also surround it. So there's 4 constellations that you need in order to find this upcoming recurrent nova. So those are all good reasons for learning your constellations. So planning. I think I mentioned planning earlier, and these are the things that I use when I plan an observing session. You have to know what your interests and goals are. You know, if you're not interested in globular clusters, then don't look at them. But you need to know that going into it so that you find all the things that you are interested in. But if you're brand new to the hobby, you may not really know exactly what your interests are. So once again, having reference material that identifies types of objects in constellations is the way to feed your interest. And your goals may include something like completing the Astronomical League's Planetary Nebula program, or the Constellation program, or whatever. Those are all the Messier, finding all the Messier objects. There's only 110 of them, and it will only take you about a year because of the seasonal nature of the sky. And that's a reason to pay attention to the calendar, to know what's available. But the time also has to do with your time. How much time do you have for a viewing session? If it's a weeknight, you're not going to have much time. So saving the travel time and being able to view at home is a good thing. But you're not going to stay out until dawn. So there's a certain limited amount of time you have. And if you know that, then you can plan for the number of objects that you want to look for and how long they'll take. Another element in the planning process is knowing the limitations of your equipment. If you know that your telescope isn't going to be able to see 14th magnitude galaxies, there's no point in trying to find them, especially with this Celestron 4-inch, whatever that is. And so knowing the limitations of your equipment and how to use it is another thing that feeds into it. And then this page is out of Sky and Telescope, and I thought it was this issue. I'm pretty sure it is. I cut off the page number so I can't find it. But this shows you the treasures in the constellation Leo and gives you a whole list of them. And so you can use that to pick out the planetary nebulas, the galaxies, the clusters, the binary star systems, and all that in order to put your list together. And so what I have here is a sample list. You go to reference stars, you go to your stellarium package, and you pick out bright stars that you just can't miss. And then click on them or go to the website called Simbad and look up through the name or however in order to get the either the Hipparcos number or the Henry Draper number in order to feed your go-to, and that'll get you started. It's better to do this kind of background stuff during the daytime rather than thrashing around at night, wasting time, wasting the darkness, rather than just have this stuff written down and available to you. Another thing is constellation reference stars. One of the ways to beat go-to problems is to know where the bright stars are and what they're called in the constellations that you'll be visiting. Because if your go-to is off by half a degree or something for whatever reason, you can go to a star that's more local to that object, do a synchronization on it, and then more than likely find it. That is one of the modes, in fact, that's in AutoStar 2, a precision mode. And it will go to a known bright star, and then you center it up, and then you hit it OK, and it'll go off and find it. You can do that manually if you have reference stars available to you. And so for my observing plan, I just put in a handful of things that are up right now, including T Coronae Borealis, because to me that's going to be a real interesting event. I mean, nova explosions are just a step below supernova, and we have hints from the professionals that this star is going to pop sometime in the next well, September, now to September, whatever that is, 3-4 months. But others say that it's more likely to go sometime before the end of next year. So we really don't know. And they can't know, even though they say it's going to go in September. But there's no way to know what the mass accumulation rate is specifically. And it will take a certain amount of mass to collect around the white dwarf before it blows up. And you can't know that. It's not regular. Question. No, actually, the T Coronae Borealis is a spectroscopic binary star. So there's a white dwarf and a red giant that are orbiting each other, and they're close enough to where the white dwarf is stealing material from the red giant, and it accumulates it. And after it accumulates enough mass, all nova will do this, but this is a recurring nova. So every 80 years, it accumulates, about 80 years, it accumulates enough mass to where it will explode. And no, just into a nova. It's not super because it doesn't destroy the white dwarf, and it doesn't disrupt the system. It doesn't blow the white dwarf away from the red giant, at least not far enough to prevent it from starting the process over again of recollecting. There are only about 10 known recurrent novas. Right now, it's sitting at a magnitude 10, and when it goes nova, it will brighten up to a magnitude 2. So that means it will be almost 1,600 times brighter at the peak of its nova outburst than it is today. And that means that it will be as bright as the alpha star in Coronae Borealis. The star that it's closest to, Eta Coronae Borealis, is a magnitude 4 star. So it will be 6 times brighter than that when it goes nova. So I think that'll be an interesting event. It's not like the eclipse, by the way. It's not 3 minutes and done. It'll take probably anywhere from a half a day to a full day to get to peak, and then it'll take a few weeks for it to descend back into its magnitude 10 world. In fact, it'll only drop 3 magnitudes in about a week. So it'll have a long tail. Be plenty of time to look at it. Okay. Thank you for the question. We'll be talking about that a little bit more here coming up. Planning example. Well, we've talked already a lot about the famous recurrent nova, and I've just explained what it is. There are papers out there that you could go look at. This is a live link. When I post it on groups.io, you can go right to that. And I ran across on YouTube Dr. Becky's podcast, and it was very interesting. It had a nice animation, and it explains quite a bit about it. And it's in the constellation Coronae Borealis. And you've seen the abbreviation a few times now. It's C, capital C, lowercase r, or capital R, B. That is the standard abbreviation for Coronae Borealis, the constellation. It reoccurs every 80 years, and just like I said, go from a mag 10 to mag 2. One of the indications that it's going to do this nova thing is that it's actually gotten dimmer than magnitude 10. So it's somewhere hovering around 11. And that's one of the indications that it's accumulated enough mass. In the 1946 explosion, the 1946 nova, they found that to be true then. How did they find that? For the last 100 years, actually since the last one 80 years before that, they've been gathering visual photometry, people going out and looking at the star and figuring out whether it was brighter than this star or dimmer than that star, and creating light curves from it. And so through the continuous gathering of light curves, they've seen that it started to dim. And so there's a lot of excitement. Excuse me?
What's the explanation for it dimming before
The white dwarf is being obscured by the disk, the gas that it's accumulating is starting to obscure it. So it's starting to get optically thick. There's just so much gas there that it's dimming the light from the white dwarf. Joke. Yes, exactly. It is a precursor that they saw in the last outburst, and they're seeing it now through the light curves that have been taken by professionals and amateurs, as reported by the AAVSO. That's happening now. You're absolutely correct. They have outbursts, they've tracked outbursts back to the 13th century, like 1272 or something like that. Yeah. That's very true. And that's why I have no confidence that that it's going to go off in September or tonight. I mean, it could go anytime. It's not on a schedule. It's not on our schedule. It could anytime. You just have to be ready for it. So get ready. So find Coronae Borealis. Go to the patch of sky that this thing lives in, so that you recognize that patch of sky, and then that will get you ready to find it when it occurs. So this is a photograph from Phil, and in order to get ready for it, this is the planning part. This is Eta Coronae Borealis right here. We have to find the constellation, which we've basically already done. We have to find the object, find some keystone pointer stars, and then field stars. And you'll see what I mean by field stars in just a moment. And then for your go-to system, if you're lucky enough, either the Henry Draper or Hipparcos number will be in the database. Unfortunately, in AutoStar 2 for the 16, it's not there. And you can see this little bitty star here, this dim star, is kind of in a sea of others. So it's not going to be real obvious until it pops which one it is. So here we are back to our sky, our constellation chart, and we already know where Coronae Borealis is. And this is how you find it. I guess this is where the animation was that I was looking for earlier. Could have put it in two places. So we found the constellation. That was pretty easy, right? That's it. And what's the next thing? So we found it. Now we need to find the object. This is a little bit. It's not detailed enough for us to do that, but it will be in this chart. So we found the constellation. We found, here's Eta Coronae Borealis. So we can find the constellation. This is a bright star. This is the alpha star right here. So this is like mag 2, and this is like magnitude 4. So it's pretty bright. Then you go to your AAVSO finder chart, And these are available. I'm not a member of AAVSO, but you can go to their website and you can print these. The one that they normally put out, the one they have available just for the asking, is a 1 degree chart. And this one's a 2 degree chart that I bluffed my way through and managed to get it to print out. So they label T Coronae Borealis with this crosshair. They put it right in the middle. T is, I think, for target. I'm not sure what the 4.3 is on this because it's magnitude 10. But these other numbers that you see on here are the magnitudes of these stars without the decimal places. So this star right here is a 10.6. This one here is a 7.9, a 9.9, an 11.2, a 9.4, et cetera, et cetera. And so from here, we want to start looking for patterns. We want to look for keystone. We have our keystone star, which is Eta. And then the next thing is to start looking for patterns, unique patterns. You can always make a straight line. It doesn't take many stars to make a straight line. So you want to look for something unique. And by the way, circles and boxes aren't very much, they're not very much better. But something like this is rather unique. That'll help us line up this chart with stellarium. And this group of 3, it's unique. And then any lines that intersect. We've got a couple of nice bright stars, but again, you can form lines anywhere you like. But there's actually a nice line of stars right here and a nice line of stars here. So we can use those to orient this chart with the stellarium chart, and with your lower power eyepieces, you'll be able to line this field up in that eyepiece and be able to locate it visually once you go to that trouble. So it's located in this area, and we still have to go a step in order to be able to see all this stuff because we still can't see TCRB in this field. So, like I said, this is our key star. If we had to star hop in here, this is where we'd start. Or if we want to make sure that our go-to is accurate, this is what we would look for. Sync up on it, and then move a very short distance over to the target. And as I mentioned, we've got some patterns that we want to also identify. We just talked about, and then confirm that. There they are on the finder chart. And it's okay to write on it because you're gonna print this out. They just give you a downloadable file, and then you print it out. So draw on it as you like. Let's see here. Okay, so here we are close enough in order to actually see everything and how all of this lines up. Now I mentioned that the 16-inch, the AutoStar 2, doesn't actually have the either the HD number or the HIP number, and I was kind of puzzled as to how I was going to find this, taking spectra of it. And my next to last gasp was trying out IC4587. And IC4587 turns out to be in the database, 14th magnitude galaxy, which I can't see in the 16 or in my finder scope, without a very long exposure, and no point in doing that. But it will take me to T Coronae Borealis with less trouble. I then plate solved to confirm that I do have the right field. But with the other stars that we just looked at, this group of 3, this group of 3, this straight line that's in there, and then there's actually, although I didn't mark it, there's a couple of other stars. Everything that you can see that's unique, you want to keep in mind, so you have a very firm set of landmarks in order to locate it. So now that you've found it, every clear night you can go out and look into the field just to get familiar with it before it pops. You'll be ahead. Pretty straightforward. This also applies to anything that you're really interested in finding, whether it's one of the galaxies, an NGC galaxy, or one of the dimmer Messier objects. You can go through all of these steps and then figure out how to optimize it later so that you don't take up quite so much time doing all this. That's with experience. So that's enough planning. Setting up, just a few comments. don't burn darkness if you can burn darkness. I was always told never burn daylight. Get it done now. Don't be burning daylight. And in this case, you want to set up early, get everything done that you can mechanically, get it pointed north as best you can, and everything else that goes with it. Do it during the day if you can, or at sunset anyway. Have I mentioned this before? Follow your manual's directions. So you've read it? No, really, you should. You can align your finder scopes, your red dot, whatever, with terrestrial objects. Ideally, you want to do that with something 1 or 2 miles away. And the reason for that is just parallax. It'll be off, but it'll be a lot closer than if you just tried it when it was dark. So low power eyepiece, something that's relatively far away. Actually, during the day, you use a high power eyepiece. I mean, at night, you would use a wide field so that you can actually get the finder scope and the OTA aligned. And obviously, when it gets dark, you do your final adjustments. You do your 2-star alignment, or just the go-to calibration if that's all it needs. Let the scope cool, and you're ready to go. Now the fun part. Any questions, comments? No? Okay. Observing. When I was out doing visual astronomy, seriously, if you will, I took copious notes, and I can sketch. So I did, and my goal of sketching was to capture what it looked like as best I could in the eyepiece, and record all of the other pertinent information: location, session duration, viewing conditions, equipment, things like that, the object description. And by the way, there's what do I write as object descriptions? Well, it was bright and it was really cool. It was amazing. But no, well, that doesn't quite tell you what it is, what it looks like. And in the backup slides, there's a set of abbreviations from the NGC catalog that kind of guide you in that description part. Abbreviations for, like, is the globular cluster rich? Is it condensed at the center? What's the magnitude of the stars surrounding it? Things like that. There's a couple of dozen that, if you look at them, it gives you a structure to work within, so that you know how to describe it, what to describe, rather than just coolest object ever, best view I've ever had. And that's good, but the 5th time it doesn't really ring true. And so this is the page. This is my log page that I finally came to. I liked the size of the circles, and there was enough lines in here to write enough information. And I would just put this together roughly at night, and then work on it the next day to make it legible and fill in gaps that I may have missed or misstated, and certainly misspelled. So anyway, object name, eyepiece used, filters used, details, and sure, emotional stuff is fine, but there should be more than just that. And a sketch. You don't have to be artistic. You just have to be able to put dots in. So I think this is a recognizable dumbbell nebula. So let's see how I did on my own outline here. Well, I said I was in the front yard. I didn't say which front yard. Was this in Fort Wayne, or was this someplace else? And it turns out I know from the date that this was from my house in Illinois. So my front yard in Hinsdale, Illinois. And the duration, right there, 2 hours, 8 to 10 p.m. And I described the evening, taking advantage of a clear night, new moon. I mentioned Jupiter and all this, but I say bad air. So somehow from bad air, I was able to get decent resolution on my sketches and in the views in order to do that. So what else did I mention here? Well, yeah, so there's the viewing conditions. Equipment, I failed on the equipment side, except for down here. I did identify the objects. So that's good. And I have some descriptive stuff in here. Let's see. Graphic. There we have, again, the catalog numbers, the the magnification, the type of eyepiece, 6.5 millimeter. So I know this was my 10-inch, which I failed to mention, my 10-inch f4.5. And here we go. It had a bright core area, had a north-south elongated appearance. It's a complex layered appearance. Unresolved glow is overlaid by many unresolved stars. Resolved members forming pairs, lines and chains, things like that. So it's a decent description. And I think that's it. Yep, there's the O2 filter, O3 filter, and done. So there you go. Post session, I review my notes. Like I said, would rewrite parts of it, make it legible so you could read it decades later. I could take these observations and go on cloudy nights and compare them, or I could open up my binder and look at other sessions to see what I saw then that I didn't in this particular session. I mean, that's one of the advantages of doing a description and doing a sketch. It forces you to look at the object and really study it. And so by doing that, you see more details in it, and you're able to just enjoy the view better. And I don't know, it just makes for a better session for me. Post session, you want to clean and fix any equipment, and then start outlining a plan for the next one. So there we go. Summary: read like your manual. Learn your equipment. Get out under the night sky as often as possible, which means at home. And if you're living under streetlights, that's really tough. And the moon isn't quite the object to get familiar with your go-to system. But hopefully you've got some bright stars. If you're really new and the operation of the telescope is brand new to you, actually finding the catalog numbers for bright stars in the various constellations and working with the go-to to see how accurate it is. I mean, you really should do that a handful of times. What will you see? You'll see a star, of course. But the point is the setup, the practice of setup, and the practice of using the equipment to get familiar with it. And then when you go out to the observatory, to a dark site, you'll be able to effectively use that evening. You'll have the experience, you'll know how it works, and you'll know what you need to do in order to make it work. So going to stars may not seem like a real exciting activity, but you're practicing. This practice. You go to the driving range for what reason? Not to make par, right? You're out there trying to improve your driving technique. You don't go to the putting green, the practice green, to make par. You're out there to get your mechanics down. And that's really kind of the equivalent of looking at stars from your backyard. So as I said earlier, I'm going to post this to the groups.io site. I'll email it to anybody that doesn't have or doesn't want to get a groups.io. I'll have a sign-up sheet, sign in for that. Also, I've scanned my log page, and if you're interested in that, I can send that to you as well. It turns out one of the really good places to get information on objects is in a database from a club called the Saguaro, what is it? Astronomy, the Saguaro Astronomy Club, SAC, the SAC, yeah. Simple name, just hard to pronounce. They have a database in there that you can use Excel, on, and so what good is that? Well, if you want to sort it by constellation, you can do that. If you want to sort it by constellation and object type, so you can find all of the planetary nebulas in Pegasus, all of the globular clusters in Leo. You can do that, and it will show you all the information. And if you're okay with Excel, it's easy, and you can download this, and it's my favorite, free. They also have log pages that you can download as well. The link to The SAC is also in my set of links in the last page. So, and then finally, although I don't expect anyone in here would be, but maybe, I'd be interested in putting together a visual viewing group aimed at newbies and anyone that would like to get out under the stars at the observatory. I'm there frequently. Yes, sir. Yes, Jefferson Township Park. Depends where you live. From here, it's about 20 minutes.
Oh.
Maybe 15. No, it's not. Except at 3 o'clock in the morning when you're going home. And trying to avoid the deer and the stray trucks. Yeah, I live northwest, so it's, yeah, a lot of expressway driving, as it turns out. So if there is, contact me or sign up, contact me. My email is visible in the Eyepiece, since I do the challenge column, and I'll be there, and I'd like to have the company. So that was fun for me. Any questions, Joe? Yes. An 8-inch Dob. An 8-inch Dob with Telrad. Yeah. Back then, it cost me about $300. It was a Coulter. Yeah. Yes, you do, and I do. I eventually rebuilt it. The mirror figure was, well, let's see, I'll be kind, terrible. It had, yes, I did. I became fair at it, not terrific. But star hopping, is annoying as it is, it's pretty cool to be able to go to a star without having to use GoTo or anything. It's actually faster. And I cite M57. Everybody knows it's between those two bright stars. So if you just go right between them, well, it's not real hard to set up other paths that are a bit more complicated than that. The most confusing part is getting the left-right reversal or the rotations, and then setting up the fields of view so that you can do that.
You ever,
No. No, I started, an IBM PC was as portable as it got. You had to have a desk with wheels on it, or the infamous luggable, and I didn't have any of that, so it was just writing it down. Ah, how did that happen? Oh, that wasn't okay. I didn't mean to. I was just trying to go to the end.
I do not particularly, but I enjoyed this.
Thank you for coming.
My pleasure.
We're available on YouTube. We have a Facebook page, so you can't miss us.
See you the next time I do so.
Great. Thanks for coming. Anyway, here's my link list. As you can see, AAVSO, Astronomical League, my favorite used bookstore, Abe Books, Friday nights, the Fort Wayne groups.io link. GOES weather satellite maps, show you the clouds in great detail. And the other one that I like to have is the Jetstream map here down at the bottom. We happen to right now are living in an area that has weather that's worse than London, England. I know that to be true because one of the people that that's in the spectroscopic group that I'm in lives near London, And he gets out and he's taken spectra multiple times per week and has been all year. And here I sit, what have you done, Joe? Well, I'm waiting for the clouds to part. Still, yes. Yeah, well, we're not much better, and we have more clouds, so there's nothing really good about. There's no advantage to us. Anyway, I also like this NGC IC project website. They have pictures of all of the NGC objects, all 7,800 of them, and you can get a preview of what they look like on that site. And it's easy, and they're not elaborate Hubble. They're really basic, so you get a good idea of what you're going to see. And here's links to the Kalamazoo sequence, and there you go. Yes. Oops. I'm back. Here's the IAU constellation abbreviation list for the 96 constellations. These are the standards that you'll see in various places, including the observing challenge. And then that descriptive list that I mentioned, the abbreviations are right here. So on whatever slide number this is, 23. So anyhow, and then some explanations or examples of how to use them. So lots of good stuff that we don't need to, that we won't go through right now. So let's see, let's find some nice pretty pictures to end on. And I have some books if you're interested in seeing the references I use. But thank you for coming and paying attention. You looked interested, so appreciate that. Thank you. I guess I should have asked if there were any before we stop. Is if there were any questions from the online attendees, the gallery. Yeah, apparently not.